Today we focused on circle applications and perfect squares. And part of accomplishing this was to remember first what was a perfect square, or what was a square, and secondly, how do we take the square root of a number? So first of all, these were our squared numbers, problems 1 through 10, and this should have been just a real quick review of what we have done last year in 6th grade. 5 squared means that I'm taking 5 and multiplying it times 5. So 5 times 5 is 25. I'm not going to continue to go over the rest of those because that should be a pretty basic concept that you picked up from 6th grade. Determine if the following numbers are perfect squares. In order for us to determine if the following numbers are perfect squares, we need to have two numbers being the same number that multiply together to give us this digit. So are there two numbers that are the same that when multiplied together are going to equal 100? Well, yes, 10 times 10 equals 100. And this is where just having those perfect squares memorized is going to make these kind of assignments much easier for you over the next 5-6 years. Number 12. Two numbers that multiply together that are the same number to give me 16. Well, 4 times 4. And if you have to, find all of your roots and find all of your multiples and then see if one of them is the same number. So I could say 1 times 16, but 1 and 16 are different numbers. 2 times 8, still 2 and 8 are different numbers. 4 times 4. Now I have the same number and it multiplies together to give me 16. $24. Now let's go the multiples way. 1 and 24 multiplied together to give me 24, but are not the same number. 2 and 12, still not the same number. 3 and 8, still not the same number. 6 and 4, not the same number. And that's all my multiples of 24, so it is not a perfect square. Another way of accomplishing that is to run through your perfect squares that you know. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Well, 24 is less than 25, and 25 is a perfect square. So 24 is not going to be a perfect square if 25 was a perfect square using 5 as its multiples. Simplify. Now is where we get to using our square root radical symbol. The square root radical symbol simply tells me to take the square root of whatever number is inside it. So the square root of 16 is 4, because 4 times 4 is 16. The square root of 81 is 9, because 9 times 9 is 81. The square root of 196 is 14, because 14 times 14 is 196. Again, this is where knowing your square roots through 25 is going to be very valuable for you in the next couple years. Now is where we start to apply that understanding towards our circle applications. So, find the exact circumference given the area. So we're given an area and we want to know the circumference. I can't find circumference without either knowing a radius or knowing a diameter. So I need to do something with this given area. Using the formula, area equals pi r squared, and the information for the given area, I can figure out the radius and then be able to find the circumference. So, since it tells me my area is 49 pi, I'm going to plug in 49 pi in place of my area. 49 pi is equal to pi r squared. And again, if you remember from class, if I divide one side by pi, I have to divide the other side by the same thing to keep my equation balanced. That will cancel pi out on one side because pi over pi is 1. And in a fraction, when I have 1, it cancels itself out. Again, pi over pi is equal to 1. So I'm left with 49 equals r squared. And here's where, now I'm trying to figure out what my r value is. So I'm going to take the square root of one side and the square root of both sides. Again, as long as I do the same thing to both sides, that keeps my equation balanced. When I take the square root of a squared number, it drops out just the variable r. When I take the square root of 49, I'm looking for what two numbers that are the same number multiply together to give me 49. And since I have my chart memorized, I know that that is 7. So my radius equals 7. Now I can figure out what my circumference is. Circumference equals 2 pi r. We just said that our r equals 7, so my circumference equals 2 times 7 times pi. 2 times 7 is 14 pi. Our question asked for me to find the exact circumference, so I don't need to do anything more with this problem than what we have just done, because I have determined that the exact circumference is 14 pi meters. Let's try one more that's just like this. Except this time, we want to know the exact area given a particular circumference. So it tells us that the circumference is 8 pi, and we know the formula for a circumference equals pi times the diameter. So I'm going to substitute in my circumference value for C. 8 pi equals pi d. Now from here we should be able to see that what is going to make d on this side of the expression equivalent to this side of the expression is to substitute in an 8 for the d. But if you still need to follow through the steps for being consistent, that's fine too. 8 pi divided by pi, that simplifies. Pi d divided by pi, because what I do to one side, I have to do to the other side of the equation. That simplifies. So 8 equals d. Now remember, our formula for area uses the radius, so we need to take this one more step and change my d into an r. And the diameter of a circle is 2 times the radius. Thus, the radius of the circle is half of the diameter. So half of 8 would be 4. Now I have enough information to start figuring out my circumference. No, sorry, my area. Area equals pi r squared. Well, since we determined that the radius is 4, my area equals pi times 4 squared. We can simplify that to 4 times 4 is 16 pi. Hopefully that gives you a good refresher or a little bit of a strong understanding for how we solve these problems. And we'll get you ready for your quiz on Thursday.